Alright, so let's continue with our partial fraction. So the video today, we are going to discuss our type 4, the fourth type, the fourth pattern of our partial fraction. Okay, so when your denominator has repeated quadratic factors, so we consider it as the fourth type now. Alright, repeated quadratic factors. Alright, so repeated quadratic factors means that, again, not as what you've seen here, when we say quadratic factor, means that you're having a square with the x. And repeated means that you have a square outside the bracket with the quadratic factor. So we call it as repeated quadratic factor. Okay, so actually for type number 4 here, we combine all the concepts that we learned before. So that means for repeated factor, you need to split it into two partial fractions, one without square, another one with the square one. And both are quadratic factor, therefore on top, both should start with, numerator should start with x power 1. So you have bx plus c and bx plus e. Okay, so for so far I didn't see any question in the past year, okay, ask for this pattern yet. Alright, so if let's say they ask you one, I will suggest you to use comparison method for this instead of using the eliminated unwanted unknown. Okay, to me, I think this method comparison will be much more easier. Alright. Okay, so again, when you are having 1 over x squared, you please take note that 1 over x squared, we consider it as a repeated root, but not the quadratic factor. Alright, to make our calculation easier, if let's say they combine partial fraction with integration later. Alright, so this is our suggestion. It is not wrong if you treat it as a quadratic factor, but we realize that if we put it as a repeated root, it will be better. Okay. Right, so I will show you the example here, example 14. So we have only one example, so I need to just show you. Okay, so this is the repeated quadratic factor because you see there's a square below the x and also the square outside the whole bracket. Alright, so the first thing is, again, you need to write out the correct pattern when you want to split it, become the partial fraction. Alright, so I will have first denominator is 1 plus x squared. The other denominator is 1 plus x squared squared. Alright, so we are having a quadratic factor here. So on top, I'm having ax plus b and then cx plus d. Your numerator should start with x power 1. Okay, then after that, what you need to do is like this whole part, you need to multiply. Okay, so you multiply it by 1 plus x squared squared. So when you multiply 1 plus x squared squared, left hand side you left only this one on. Alright, and then for your right hand side, first partial fraction you have this, and the second partial fraction you have nothing. Cx plus d only. Okay, alright. So for what I suggest is for quadratic, repeated quadratic factor, the easier one will be you do the comparison. So to do the comparison, you need to expand everything. So that means you're having ax plus ax cubed plus b plus bx squared. Then plus cx plus d. And after that, the next step is you need to group all the same power x together. So you're having ax power 3. And then you're having bx squared. Then you're having a plus cx. And then you're having b plus d. And you need to compare left hand side with right hand side. Okay, so the comparison here is also very simple because if you look at ax power 3, alright, so if you compare it left hand side, is there any x power 3 there? No, right? So that means your coefficient of x power 3 is 0, which means a equals to 0. The same thing happened here. You compare the b with the coefficient on the left hand side of x squared. Alright, so you're having negative x squared. Compare it with bx squared. Therefore, from here you can surely get an answer which is b equals to negative 1. Alright, so you can see comparison in this kind of question is very, very simple and straightforward. Okay, and after that, I make a mistake here. Alright, so the x should be outside. Okay, then the next one is you compare like a plus cx, alright, together with the term, x term on the left. But you didn't see any x here, right? X power 1. Therefore, it means a plus c is equals to 0. And then because just now you already know that a equals to 0, so c also equals to 0. All right, then the last one is b. b plus d is a constant term. You compare it with 1. So just now b already know that it is -1. Substitute it inside and you'll get d equals to 2. So you can see that by using comparison method, it looks like very much simple. Okay, if you compare it with the other, if you use comparison, right? So it will be better if you use comparison in this pattern. All right, then after that, after you get all the value here, then you rewrite again. Always remember to rewrite your complete partial fraction answer again at the final sentence, okay, at the end of your answer. So that means you should have -1 over 1 plus x squared plus 2 over 1 plus x squared squared. So this is the partial fraction for the repeated quadratic factor. Okay, so I can only find out this example for you to refer because I never seen any other example like this yet in the partial question. Okay, so hopefully your ear will come up, but actually it's not part, right? It is still very simple. Okay, so just make sure that you know how to write out correct partial fraction pattern for the repeated quadratic factor. Okay, all right, so we proceed to the next part. We already completed all the 4 patterns for our proper fraction. Do you remember before that I told you that our rational function, we got proper fraction and improper fraction. So for proper fraction, we have 4 parts, type 1, type 2, type 3, and type 4. We already completed everything here. Okay, and if you check back all these 4 types of pattern, all the examples that we try are proper fractions. Okay, so what is a proper fraction? Again, look for the notes and then see what is the definition again if you already forget. Okay, so for today, we will proceed to the improper fraction. So improper fraction, generally the concept are more or less just that before you do the partial fraction, right, you need to do 1 step extra, which is long division. Okay, so let's have a look at how we do it. All right. Okay, so let's proceed to the improper fraction part. Okay, so for improper fraction, again, generally when the degree on top is equals to or greater than the degree at the bottom. Okay, all right, so that means like this example, on top numerator is x power 3, at the bottom is x power 2. So the numerator on top, the degree, is greater than the degree of denominator. So in this case, we know that it is improper fraction. Therefore, when you want to do the partial fraction, right, generally you will see that in front of it, you have a polynomial or maybe a number. Okay, then plus only followed by the partial fraction at the end. Okay, all right, so now how can you get the polynomial here? Okay, so for the polynomial here, generally is the quotient, okay, that you get when you apply long division. Because just now I asked you to, I tell you that for improper fraction, there's 1 step extra, right? So you need to do the long division. So the quotient for long division is actually this answer. And then this one, before you split it become the partial fraction, it is actually the remainder, okay, of the long division. So from this remainder over the divisor, from this part only you split into partial fraction. So the way that you split it into the partial fraction, follow all the methods that we learned before, okay, for type 1, type 2, type 3, or type 4, up to you. Okay, all right, so generally this is the idea that we have. Okay, so for improper fraction, you need to apply the long division first. So the long division, you will get quotient and remainder. So the quotient, you put it here, remainder, you put it as the function. Then after that, only you use this part to split it into partial fractions. Okay, all right. So in general, you will see that this is a very general example. Okay, so if let's say I'm having degree on top is x squared, degree at the bottom is also x squared, right? So it is still improper fraction. So now, first you need to know that you need to use long division to find a. So this is the quotient actually. And after that, you use the remainder to find the b and c. Okay, so usually in the exam, the question will not tell you that this is an improper fraction. So every time you have to check carefully whether is this an improper fraction or not. And I can tell you that this is a very, very common mistake that students will do, because usually when they look at this question, they are not going to check. They will straight away start with the partial fraction. But they forget that maybe they have improper fraction in the question and they need to apply long division, because the question will not give you any hint. Alright, so if you didn't apply the long division and you straight away proceed with the partial fraction, right? I will tell you the answer will be correct one. Alright, so this is a very common mistake. So please take note of this. Okay, really, really common. I can see a lot of good students also, they didn't check actually, they forget already lah. Okay, because improper fractions, maybe they did maybe a few questions only. Alright, not many. So in exam, they always forget about it. Right? Okay, so let's start. Okay, so for example, 15. For me, I will try part A, you try part B yourself. So for part A again, so from now onwards, when you look at the rational function and they want you to split it into the partial fraction, right? The first thing is you check on the degree first. So the degree on top is 2. The degree at the bottom, you take s times x is x squared, also 2. So when the degree on top and also the bottom are the same, they already is an improper fraction. Okay, so how to do the improper fraction? For the bottom part here, if you expand everything, you will have x squared minus 2x minus 3. So that means you need to apply the long division first. So first step is long division. You're having x squared here, and then you're having x squared minus 2x minus 3. Divided means the divisor. Alright, okay. So okay, something multiply with x squared to get x squared. So what is the something here? It should be a 1. Okay, so if you continue with the long division, you have x squared minus 2x minus 3. So 0 minus 2x, 0 minus negative 2x, you get 2x. 0 minus negative 3, you get positive 3. So this is a quotient, and this is the remainder, right? Okay, so first, you can write out like this. So your x squared over x plus 1 and also x minus 3 is 1, then plus 2x plus 3 over x plus 1 and also x minus 3. So you know that this is quotient and this is remainder. Alright? Okay. Then now you need to focus on this. From here, you want to split it the partial fraction. So this is proper fraction already, like what we learned before. All these are proper fraction now. So from this proper fraction, I want to split it into partial fractions. Okay, so if you look at this question here, it actually belongs to linear factor. So I'm having x plus 1 with a on top, then x minus 3 with b on top. Okay, so again, I'm not going to show you all the details now. So multiply the denominator, you should get a x minus 3 plus b x plus 1. So what I need to do is I let x equals to 3. 3 times 2 is a 6 plus 3 is a 9. Equals to 3 minus 3 is a 0. So 3 plus 1 is a 4. So you're having 4b on the right. Okay, so you're having 4b on the right hand side, and therefore what is the value of b? It will be 9 over 4. Okay, and after that you let x equals to negative 1. So when x equals negative 1, on the left you have 1 here, and then on the right you have negative 4a. So your a is also negative 1 over 4. Okay, so from here you roughly know that, okay, for 2x minus 3, you can split it become so you can split it become negative 1 over 4 x plus 1 plus 9 over 4 x minus 3. Alright, so you bring it back to the original answer here, so you can continue here. So the original answer will be 1 plus, right? Because here is a minus of you, so you put it up minus negative 1 minus 1 over 4, then x plus 1, then plus 9 over 4 x minus 3. Okay, so this is your correct final answer for the partial fraction. Okay, but this is the improper fraction. Alright, so you need to carry out one step extra, which is the long division. And after that, you use your quotient. So just a reminder for you, this is your quotient. Okay, and this one is your remainder. And then from the remainder rational function, right, only you proceed with the partial fraction steps that you learned before. Okay, so it doesn't really hard. Alright, so just that you need to be very careful. You make sure you double check whether is it the improper fraction or not before the exam. Okay, in the exam. So you please remember to check it. Alright. Okay, so you try the part B yourself. So I put it under this part, obviously is improper fraction. Okay, so just tell you that the answer is 1 minus 2x plus 1 divided by 5 x squared plus 1, then minus 8 over 5x plus 2. Okay, so please try out this example and see whether you can get the answer correctly or not. Alright, so here we ended our our third subtopic for the algebra, so partial fraction. Okay, it is quite long actually, but once you already manage to know how to use the method correctly, then it is actually very simple. Alright, okay, so make sure you try out more questions at the end of the in the exercise that I provided to you. Alright, at the end of every chapter. So make sure you try all. Although some questions will be quite simple, but it is a very good practice for you to catch up with all the details for all the methods that you learn here. Okay, so you don't expect that, I look at the example for a few questions, I already understand how to do it, and then you can answer all the questions. No, you have to practice so that the flow will go very smoothly. Okay. Alright, so for this video, I think I will stop here. And then for the next video, we are going to discuss the last subtopic, the fourth subtopic for this chapter 1, which is the binomial expansion. Alright, so you'll see you in the next video.